everyone, my name is Anya, and today on Math and Science Concepts, we are going to be talking about the science of matter and change.
And I'm Tina, and this is the very first video of a series of chemistry videos that Anya is going to be doing for you guys, which is going to be very informative and have detailed chemistry concepts for you to learn and grow with it. So,
like, share, and subscribe, and hit the notifications bell so that you never miss another one of my chemistry videos. So, let's get started. Science is everywhere, and a part of science is chemistry. Chemistry is fun. It can be used to make colors change, alter recipes, color flames, make things glow in the dark, or even make stuff explode. Many people study chemistry not because it's a requirement for class, but because they are interested in using it to explore the world and to try science projects. As hobbies go, chemistry is inexpensive because home chemicals can be used to perform many interesting experiments.
Anya, can you talk about the word chemistry as to where it comes into existence from?
Yes, the word chemistry comes from the word alchemy. As early as 1000 BCE, alchemists sought the philosopher's stone, which could turn any metal into gold. Today, we know that there is no such thing as a philosopher's stone. Even though they were not successful, alchemists discovered some of the basic principles of science we still use today. They discovered how to extract metal from ores, make pottery and dyes, and other ways to manipulate matter. Modern chemistry is the study of matter.
So, why is chemistry important?
Yeah, so have you ever seen a label on a product that touts it as being chemical free?
I think I have.
The term chemical free can be used to denote something as being natural or safe. But can anything really be chemical free?
I wouldn't think so.
Yeah, the word chemical literally means any substance made of atoms. The cleanest water contains a pure chemical made up of hydrogen and oxygen. Fresh fruits and vegetables are grown in soil mixed with potassium, nitrogen, and phosphorus and contain citric acid found in lemons, beta-carotene found in carrots, and capsaicin found in red peppers. In fact, a bag with a chemical-free label should have nothing in it, not even air, because air contains chemicals too. Everything you could come in contact with is made of chemicals. The clothes you wear, the pen you write with, the air you breathe, the food you eat, and even you are a mixture of chemicals. The word chemical can be applied to you and every substance around you.
So chemistry is really everywhere, right?
Yeah, not only is the world full of chemicals, but those chemicals are constantly changing. You see examples of this every day, such as when water evaporates on a warm day, plants grow in sunlight, batteries generate electricity, and food is digested. The study of the chemicals that make up the world and the changes that they undergo is chemistry. What does this have to do with you? As you gain more knowledge about chemistry, your understanding and appreciation of the world around you will increase. So, in the end, you will see that chemistry is not just a class you take in school, it's essential to
Wow,
life.
that is super interesting. So, would you like to talk a little bit more about um, why, how is chemistry like related to everything around us? Like you're saying that chemistry is the study of matter and how it changes everything and how everything changes and alters, right? So, can you throw some light on that for us, please?
Yes, chemistry is the study of matter, and the simple definition of matter is stuff that has mass and takes up space. In chemistry, we need to dig deep. We ask questions like, what is matter made of? How do we explain the infinite variety of matter around us? In your immediate vicinity, you might reach out and touch wood, feel metal, orange juice, skin, hair, rubber, plastic. The list has no end.
So, and how does all of this change happens with chemistry?
Yeah, ice melts into liquid water and gasoline burns into carbon dioxide, water, and trace gases, excuse me. When food is digested, plant leaves are digested and are converted into energy, waste, and the material that makes up your body. Both the living and non-living worlds are places of continuous changes in matter. Chemistry provides the explanation for how and why matter changes. Why does wood easily change to ashes and smoke, but lead does not easily change to gold?
Interesting. I had another thought in my mind while you were talking about all of these changes. How is chemistry linked to technology as you've mentioned there on your slide?
Uh, there is a technological benefit to understanding matter and change. Once we understand the processes of chemistry, we have the ability to shape both matter and change it to suit our needs and solve human problems. The creation of vitamins and medicines is done through chemistry. Advanced materials such as carbon fiber and super strong metal alloys are achieved through chemistry. Everyday substances from dishwashing soap to glue to colored glass, these all owe their existence to chemistry. Virtually every human made item you have ever used or will ever use owes some or all of this existence to chemistry.
Great information. Let's move on to the next slide here.
And chemistry is essential. And chemistry is important in everyday life because everything is made of chemicals. You are made of chemicals. I am made of chemicals. So is our dog. Our refrigerator uses physics and chemistry. All our medicines are chemicals. Food is made with chemistry. It's everywhere.
Right.
All life depends on chemical processes. uh, the chemical process of photosynthesis, which uses the sun's energy to convert water and carbon dioxide into glucose and oxygen, forms the base of most food chains. So, why is chemistry called the central science? Chemistry is the central science because its concepts are at the core of other sciences and applied sciences. So as you can see here, chemistry as the at the center, and it's connected to all these other sciences such as physics, nuclear science, geology, environmental science, astronomy, and biology. It's connected to everything.
So everything is kind of interlinked and chemistry is at the center of it, right?
Yeah, chemistry is fundamentally important. Everybody ought to understand enough chemistry to make informed decisions in their lives. Every day we face a range of questions as simple as what to eat and as complex as whether Earth's climate will change and why. Memorizing how to solve these types of problems in a book will not prepare people to answer these questions. To use chemistry, people need to understand chemistry, the underlying concepts, as well as how to solve realistic problems. This is the goal of chemistry. You may find some of our uh, chemistry techniques different, but thousands of people show that chemistry is extremely important inquiry based techniques that create a deeper learning that lasts.
That is great information. So you said that the answer is that chemistry fits in the center. And to understand biology, you need to know the chemical basis for living organisms, right? And to understand chemistry, one needs to know about atoms, energy, and systems. And these are the domain of physics, correct?
Yeah, chemistry is a bridge between the most fundamental properties of our universe, energy, mass, force, and atoms, and the most complex system in the universe, a living organism.
Right. So physics is the most basic branches of science. Physics describes the laws that govern the behavior of objects and energy. And at the opposite end of the complexity spectrum is biology, ecology, and the life sciences, right?
Yeah, if you think about physics as explaining atoms, then chemistry explains how the atoms come together in millions of different chemicals that undergo billions of different reactions to make other chemicals. Biology takes the millions of chemicals and billions of reactions and organizes them into an extraordinarily complex interconnected system that is a living organism and environments. Did
That's very interesting, and as complex as it sounds, it's really very simple, correct? And if I can talk about a little bit of the chemistry and the biology link, uh, do we have something of the chemistry that is going on in the cells, say
Yeah,
of the living organisms, be it humans or plants or, you know, anything like microbes, bacteria?
yeah. The cell is the building block of our body, and cells carry out many reactions to support our lives. They include generating energy for our daily activities, detox toxic substances, and many others. Many of these reactions involve chemical reactions or chemistry. The knowledge from studying chemistry of these reactions can be used to improve and better our lives.
Interesting. So there is a lot that chemistry has done for us, right? Let's move on to the next slide and see what we have.
Yeah, so I want you to pause for a second and look at this and appreciate what has chemistry done for us. I'll give you a second to pause.
And these are just a few examples. There's much more that chemistry has done for us.
Yeah, so let's move on. Uh, so French philosopher Auguste Comte developed a hierarchical classification organizing the sciences into a general framework. His diagram orders the sciences as logic, math, astronomy, physics, chemistry, biology, and the social sciences. Chemistry is fundamental to biology because it provides a methodology for studying and understanding the molecules that compose cells. Chemistry and physics are both needed in the areas of physical chemistry, nuclear chemistry, and theoretical chemistry. Chemistry and biology intersect in the areas of biochemistry, medicinal chemistry, molecular biology, chemical biology, and molecular genetics and immunochemistry. Chemistry and the earth sciences, intersect in areas like geochemistry and hydrology.
That's like an immense connection. It is not only connected to human beings, um, things that we need to use on our daily in our daily lives. It's also very it is very complex, and it is also connecting chemistry is connecting our earth in many different ways that we don't really realize that it does, right?
Yeah, so the relationship between the sciences, just like I explained for chemistry, lies in physics. The fundamental processes of biology are explained by chemistry. Chemistry connects the inanimate world of physics to the living world of biology.
Correct. So let's move on to this slide and see what we have.
So, science is an ongoing process. Science is always evolving, and that's why it is an unstoppable process. As long as humanity exists, progress will happen, and every progress underlies its core scientific factors and influences. Scientific ideas are developed through reasoning. The scientific method is formal, logical, and thought based. It is also the natural cycle of learning, like questioning, trying out, and remembering and revising. The scientific way of learning is often slow and cautious and accepting of only evidence based on documented conclusions. So, as you can see here in this diagram, the first step is to make an observation. And then you think of an interesting question about those observations. And then you formulate a hypothesis that could answer your question. And then you develop testable predictions. You gather data to test the predictions and then refine, expand, or reject the hypothesis depending on your results. And then continue this process until you are satisfied with the result. And then you develop a general theory based on the answer to your question. And then you continue making observations, and this cycle continues. By the time a scientific explanation reaches the status of a proven theory, the explanation and details of it have been compared to a multitude of observations, data, facts, and found to be in agreement with all of it. Even one discrepancy would mean that that explanation is inadequate.
So it is a long process, but it definitely finds the truth of the in the core of the issue or the question that that somebody might have, right?
Yeah, that is very true.
Great. Moving on to the next slide, here we are talking a lot about scientific process. The first thing that we have here is inquiry. Let's talk about that a little more, Anya.
Yeah. The primary goal of science is to discover the natural laws hidden in the behavior of the universe. The primary way we accomplish this is through the process of inquiry. The process of inquiry starts with asking questions and proceeds by comparing possible answers to what is known and what is newly discovered. An inquiry is like a crime investigation in which we must unravel the clues to discover what really happened. In a scientific inquiry, the clues for natural laws are what we actually observe to happen, and the mystery is a theory explaining why things happen the way they do.
So, scientific inquiry is an ongoing process in its truest sense.
Yeah, today's new questions are being asked like what happens if a material such as silicon freezes very fast? Does it change its properties? The answer is yes, the properties do change. And fast frozen silicon has different electronic properties. New knowledge is being added as we ask new questions that build on what we already know.
Right. And I want to know a little bit more about hypotheses that you have mentioned over here. I do know that hypotheses is like forming an opinion.
Yeah, a hypothesis is a tentative explanation or conclusion about the physical world. Hypotheses do not have to be right. The logic of science assumes a hypothesis is correct and seeks scientific evidence that either supports or refutes the hypothesis. Hypotheses are tentative statements which may or may not be correct, testable statements that can be tested against scientific evidence, and necessary and fundamental steps in developing reliable scientific theories.
So, as if a student of science, if I were to understand, the development of scientific knowledge is inquiry, which is posing questions, that moves on to hypotheses, which has the potential answers, which may be tested against scientific evidence, and which in turn forms scientific theories, which are well tested explanations, which are supported by all known scientific evidences, correct?
Yeah, a scientific theory is a comprehensive and well tested explanation of a natural or physical phenomena. Unlike hypotheses, scientific theories are well established and highly reliable explanations that have been tested by multiple independent researchers over a long period of time and under a wide range of conditions. In many ways, the knowledge of science can be grouped roughly into the following categories: facts and data that describe what we know, theories that provide explanations consistent with all known facts and data, ways of learning such as procedures, techniques, and tools that allow us to collect information, and the scientific method framework for reliably sorting truth from competing ideas.
Right. Care to explain this bird beak diagram which you have presented over here?
Yeah, here we see the most famous example of Darwin's Galapagos finches. From 1831 to 1838, Darwin traveled around the world observing animals on different continents and islands. On the Galapagos Islands, Darwin observed several species of finches with unique beak shapes. These birds, although nearly identical in all other ways to mainland finches, had different beaks. Darwin observed the Galapagos finches had different beaks. The finches had a graded series of beak sizes and shapes, and predicted these species were modified from one original mainland species. Darwin called the differences among species natural selection, which is caused by the inheritance of traits, competition between individuals, and the variation of traits. Their beaks had adapted to the type of food they ate in order to fill the different riches and niches on the Galapagos Islands. Finally, the changes in the genetic composition of a population over successive generations was noted.
Awesome. Let's move on to the next slide and see what we have here. This slide is talking about key points of a good experiment. Let's discuss a little bit more, Anya.
The experiments are a core part of science, and experiments must be conformed. An experiment is a controlled situation created specifically to collect scientific evidence by observing what happens. Experiments are a core part of science because the evidence must be collected objectively and must be confirmed by others who repeat the same experiment. Experiments must be exploratory to see what happens without specifically testing any preconceived idea. However, experiments are often set up to test a specific hypothesis. The important criteria are that an experiment be repeatable, generate objective scientific evidence, and provide a clear way to interpret the evidence, positive or negative. This last requirement is the difference between a good experiment design and a poor one. A claim is a statement that asserts something is true. A scientific claim must be supported by scientific evidence. For example, bleach is a common household cleaner which removes stains by chemical action. Advertisements for bleach claim that they work equally well in hot or cold water. An experiment to see if the water temperature affects the rate at which bleach removes the stains from food dye would be a good way to collect scientific evidence to test this claim. For example, you could set up the experiment like this. Prepare 5 cuvettes with 1 drop of dye in 2 milliliters of distilled water, and then heat the cuvettes in water bath to 5 different temperatures. The cuvette A could be 10 Celsius, and cuvette B could be 20 degrees Celsius. Cuvette C could be 30 degrees Celsius. Cuvette D could be 40 degrees Celsius, and cuvette E could be 50 degrees Celsius. Then add 5 drops of bleach to each cuvette, and then observe the color after 5 minutes of each cuvette.
So a good experiment design starts with the procedure which describes the methods used to collect the evidence, right?
Yeah, the procedure should include all important setup details and describe every important step and measurement. For example, set up the cuvettes, as I said before, and then the procedure should be clear and detailed enough that somebody can replicate the same experiment the same way.
A conclusion after that is a statement that the experimenter believes represents the results of an experiment or observation, correct?
Yes. For example, in the experiment stated, if the stain was removed in the higher temperature water and not in the lower temperature water, a conclusion might be that the bleach does not work at colder temperatures. However, what happens after 10 minutes or 20 minutes? If you do this experiment, you will find that bleach takes longer time to act at colder temperatures. The soaking time effect is important and not designed for in the experiment. This error in experiment design might cause an incorrect conclusion. A good experiment design should include controlling all variables, such as time and temperature, that affect the observed results.
So what is a variable?
A variable is something that can be measured or changed in an experiment. Experimental variables are variables that we're trying to measure, and controlled variables are variables that we control and are constant and keep the same.
Right. So that explains what a good experiment would look like, right?
Yeah, so science is never finished. Science is an ongoing process, and there are no absolute truths in science because there are limits to everything we know. For example, the gravitational laws are well proven truths on the macroscopic scale, but we still do not understand gravity on the microscopic scale. The scientific method requires that we continue to develop, refine theories to explain more and more different phenomena. As humans create better ways to observe, such as atomic force microscopes that can see single atoms, we make new observations that lead deeper understandings in the way that theories explain more aspects of nature.
So, from what I understand, in science is never finished because you earlier said that it was an ongoing process. And the scientific method is supposed to be more of a formal explanation of what goes around and what happens and how things change and how things work for us or how things exist or how are different things developed for and will be developed in the future. So it is more of a logical and thought provoking process. It is also the natural cycle of learning, and we use this kind of learning throughout our lives as we question, we try, and we remember and revise. The scientific method is the natural way of learning, right?
Yeah.
And I also learned from you today that the formal scientific method is that scientists observe nature, then consider possible reasons that might explain the phenomenon. Hypotheses are created, then tested against evidence, collected from observations and experiments. The hypotheses are modified and retested, and then a hypothesis which is correctly accounts for all of the evidence that every experiment is a potentially correct theory, right? And then theory is put to test when scientists collect new evidence. All it takes is one piece of evidence that disagrees with that theory to cause the scientist to return to step one. And if necessary, the theories will be revised. So So that is when science is never finished, correct?
Yes, and with this, we come to the end of our presentation for today. See you at Math and Science Concepts with more informative videos very soon. Bye bye.
Bye.